For the third property of the electric charge is that the charge is constant. The electric charge is constant. It means that if we put an amount of charge to an object, okay, if I have an object and I put some positive charge into this object, this positive charge must come from somewhere. It cannot happen by itself. It must come from somewhere. For example, like if we rub, if we think that this is a glass rod, and if we rub this glass rod with the silk, and we introduce the positive charge in the glass rod, it means that the positive charge comes from the silk to the glass rod. And it means that we introduce the same amount of the charge but have a different sign, which is a negative charge on the silk, because it is charge transfer between the glass rod and the silk. Okay, this is the charge transfer between the glass and the silk. Okay, if you transfer the positive charge to the glass, it means that you leave the negative charge on the silk. The charge cannot be created or destroyed. So we say that the charge is constant. Nowadays we know that this charge transfer comes from the transfer of the electron. So it means that in this case, the electron is transferred from the glass to the silk. Equivalently, it means that we increase we introduce the positive charge on the glass, because when the electron leaves the glass, it introduces the positive charge, or it left the positive charge in the glass, because before the system is in equilibrium, in electrical equilibrium or electrical neutral, means that the same amount of positive and negative charge is in the glass. But if you transfer some negative charge, which is the electron, to the silk, it means that you leave some positive charge on the glass. But the total amount of the charge must be the same. So we say that the electric charge is conserved. And for the last property here is that the electric charge is discrete. It means that any amount of the electric charge, whether or not positive or negative, whether positive or negative, if we have an amount of the charge, we can write down this as n time of the fundamental charge, which is the charge of the electron. Okay. Anyway, if this is a positive, we will use the absolute sign here. Means that we take all the magnitude of the charge, and it depends and have the minus or a plus or minus here. It depends on what is the sign of Q. Okay. Anyway, the main point here is that the amount of charge is the integral multiple n is an integer. So Q is the integral multiple of the fundamental charge. Fundamental charge, which is the charge of the electron. Okay. Anyway, if we look at the value of the electron charge, it is about let's see, electric charge 1.6 times 10 to the minus 19. 1.6 times 10 to the minus 19 Coulomb. We will talk about the unit Coulomb later. Anyway, you can see that the number is very small. It's very small. So, in general case, except when we deal with the phenomena in the atomic scale or smaller, we can safely say that Q is approximately continuous. Okay, we can safely say that Q is approximately continuous because the state of the fundamental charge is very small. So it means that if we look at the scale, if Q is large enough, you can see that the scale of the fundamental charge is very small. So we can approximately this as a continuous scale. Okay, so this is the 4 basic property of the electric charge. Okay, next we will see that from the knowledge of the electric charge, we can categorize the material due to the electrical property, and that is related to the electric charge.